Hey there, welcome back. Let's check couple of more things related to lambdas. In order to understand this, first of all, we will be creating a variable. The name of the variable could be like x, and we can initialize this with 10. Now moving forward, let us create a new thread, and we will make use of the shortest possible path. So we will type in new thread dot start, and we will pass on a new runnable object but taking help of lambda. So in here we will type in pair of parentheses, then arrow token, then arrow token, and then finally the statement. So it would be like sys out. Alright, so the autocomplete won't work in here, so let's type in system.out.println, and in here we will pass on the value of x. So the message would be the value of x is, and we will display the value of x. So till now there is nothing new which we have doing. If I execute the program, definitely we would be able to print this. Now there is a twist in the story. In here, for example, I add a yet another statement which involves modification, updation on this particular variable x, or in fact some operation on this variable x. Then there would be some magical output. There would be a crash. Now in here, if I show you what is the error message, the error message is local variable x defined in an enclosing scope must be final or effectively final. So in here it needs to be final or effectively final, and if we are performing any kind of operation on this variable, our program will give us an crash. It will not execute properly. Now why there is this crash? Now friends, when we are making use of a lambda expression, this could be a thread, this could be a lambda expression for some other functional interface, but the major point is that when we are executing this operation x++, it might happen that the sequence of execution is different. Why? Because this line of statement is a thread, and these two line of statement are statements in some other thread. So it might happen that the sequence is, first of all, we declare the variable x and we initialize this, then the thread gets executed and the value of x is printed as 10, and then increment of x performs. Now this may cause issues. This is the reason why Java doesn't allow non-final variables or effectively non-final variable to make use inside our lambda expression or inside our anonymous inner class. Now friends, what's a final variable? A final variable is a variable where we explicitly make use of final keyword like this. So as soon as we make a variable as a final variable, no changes would be allowed. What is a effectively final variable? A effectively final variable is a variable where we don't make any further changes once the value is initialized. So in here, once we have initialized this variable x as 10, this is effectively final variable because there is no further modification, there is no further operation which is performed on this variable. As a result, we can make use of this variable inside our lambda expression or inside our anonymous inner class. So this is one thing. Moreover, let us quickly check an interesting thing once again. This is known as a for each loop or enhanced for loop, to be more specific. So first of all, let us create a list. So in here I will type in list. It would be list of integers. The name of the list would be like list equals new array list. Here we go. And then we need to also add the required import. Let's do that. All right, so I will quickly add couple of elements in here. All right, so this is the usual list. Then we will make use of a for each loop, or in fact it is also known as enhanced for loop. So in here I will type an integer I may be colon list Here we go. And inside our loop we will simply print I. Right, and if we execute this program, definitely we will get a list of values which are there in our list, which is cool, right? Alright, so now let's add a if condition in here. It would be like if I is greater than 10, maybe greater than equal to 10 maybe, and in this scenario we would be printing the output on the console. So this is a very simple and easy to understand condition which we have added, and again our loop is working properly, and this is the usual stuff. Now similarly we can also perform the same operation using a for each loop. Now this is a different for each loop. This loop which we have already seen, this is known as a enhanced for loop. Again, there is a yet another version of for loop. Let me show you. Now in here we will type in list dot for each. So in here, this is interesting. We will make use of for each, and inside pair of parentheses where it is shown as action, we will pass a lambda expression. Now this expression is smart. In here, first of all, we will make use of a name. This name is a temporary variable name. This would be, for example, I. Now friends, take a note of it that for each doesn't require a data type of the temporary variable. It will smartly identify the data type of the temporary variable, which is amazing. Then we will have the arrow token. Let me add it, and then a statement. Now if inside your for each loop there is only one statement, then there is no need of braces and a single statement is working. Let me execute and show you. This will work. Now for example, if we want to add a restriction similar to this example before, then definitely we will add braces. Let me add pair of braces real quick, and let me format this a little as well in order to make this more readable. Alright, so now we can add a if condition, and the condition would be if I is greater than equal to 10. In that case, we will print the value in our console. Let me format things a little. Alright, so this looks good, and here is the output, which is perfect, right? So this is working perfectly, and this is a yet another way how we can make use of for each. Now this is a enhanced version of for each, and I suppose we need some more examples. So let me do one more thing. Let me try to show you how we can handle things with a reference to custom objects, where we iterate over custom objects. Now let us add what we say a class by the name of data, and in here we will make use of a private entity, private string name, and we will add a constructor for the same. I will right click, navigate to source, and add a constructor using field. Then moving forward, let us also what we say add a toString method real quick. So let's do that. Alright, so this looks good to me, and let us also add a getter method that will give us a better view, and that will help us. Here we go. So the class is ready, and in here we won't be creating a list of integer directly. We will create a list of data. Alright, and in here let us create objects of data type. So I will type in new data, and the name could be like my name, right? Let me get rid of these statements, and let me copy this line of code and paste it couple of times, and let me also get rid of this. The next name could be like John. Alright, so let me get rid of this, and now let us add a fresh for each loop. So it would be like list dot for each, and in here, as we know, we need to give a temporary variable name. So it would be like temp, then arrow token, and then pair of braces, and inside this pair of braces we can definitely add in what we say statements. So it could be like sysout, and in here we can type in temp dot get name. Right, so this is pretty simple, right? And if I execute the program, this will definitely give us the name of the list. So this is all about for each and some small little details related to what we say Lambda expression. So this is it. In our next video, we will try to understand what exactly is a predicate. That would be interesting. Hope you guys enjoyed it.